Hey everyone, and welcome to this explainer on NCP-MCI 7.5, 12.7 virtual networks, failover types, and recovery. If you're an infrastructure admin gearing up for the Nutanix NCP-MCI 7.5 certification, you are in exactly the right place. Today, we're diving straight into the core mechanics you absolutely must master to pass section 12.7. And look, this isn't just about memorizing which buttons to click. It's really about understanding the underlying architecture that keeps enterprise environments breathing during a full-blown disaster. Let's get you ready to crush that exam. Okay, so here's our game plan for today. We're going to cover why virtual networks matter, mapping virtual networks, executing failovers, manual recovery and replication, common exam traps, and then we'll wrap up with a cheat sheet of key facts to memorize. All right, let's jump into section 1, why virtual networks matter, specifically focusing on isolation and integrity. So when you're building out a recovery plan, network isolation and mapping are completely non-negotiable for system integrity. I mean, you literally cannot afford to have a test failover suddenly stepping on the toes of your live production environment, right? But before we get too deep into those complex configurations, let's quickly define a couple of baseline acronyms just to prevent any cognitive overload. AZ stands for Availability Zone. Think of this as a distinct, isolated location within a cloud or on-premises environment. And DRaaS stands for Disaster Recovery as a Service, because, IT definitely doesn't have quite enough as-a-service acronyms yet. In the Nutanix ecosystem, this often involves pairing your on-premises AZ with the Nutanix Cloud AZ to protect your workloads. Understanding how these locations talk to each other, that's the entire foundation of network mapping. Moving right along to Section 2, a walkthrough of mapping virtual networks and those core mapping mechanics. This mapping concept is our first core mechanic, and trust me, it is heavily tested. To really grasp cloud mappings, you first need to remember what a VPC actually is. A virtual private cloud, or VPC, is just a logically isolated section of the cloud where you can launch resources in a virtual network that you get to define. In Nutanix cloud services, VPCs are built in specifically to handle your failover traffic securely. And this brilliantly illustrates that concept. Notice how the physical location on the left, so your on-premises data center, has user-configured virtual subnets for both production and test. Those map directly over to the built-in production and test VPCs sitting in the cloud on the right. When you sit down to create a recovery plan, you are literally drawing these lines so the system knows exactly where to send your VMs when a failover is triggered. But here is a critical distinction you absolutely need to stash in your back pocket for the exam. At your on-premises AZs, you have to manually create the production and test virtual networks before you configure your first recovery plan. They're just virtual subnets bound to a single VLAN. In contrast to that, a Nutanix Cloud AZ creates the production and test virtual networks dynamically for you. Plus, the Nutanix Cloud AZ provides floating IP addresses, which is a feature that's simply not available for on-prem AZs. Keep that difference in mind. It's a real game changer on the test. All right, Section 3, executing failovers and understanding traffic routing logic. So once your networks are actually mapped out, how does traffic really move when a disaster strikes? Or, when you just initiate a routine test? Let's trace the routing logic here. Following the blue arrows, you can see that for a planned or unplanned failover, meaning an actual disaster or a deliberate migration, your primary production network maps directly to the recovery location's production network. But check out the orange arrows for a test failover. In that scenario, your primary production network maps to the recovery location's test network instead. The underlying why here is absolutely vital, both for your real-world job and the exam. We map test networks during a test failover to ensure that the testing environment is totally confined. The guest VMs at the primary AZ, they aren't affected at all. This strict isolation is what allows you to validate your entire DR strategy right in the middle of the workday without dropping a single packet of your primary production workloads. Okay, on to Section 4, manual recovery and replication methods. Now, while Nutanix definitely excels at automation, you are still expected to know the manual recovery steps. Specifically, you need to know how out-of-band snapshots must be manually created and replicated when you aren't relying entirely on automated protection policies. A huge part of this manual recovery involves file-level restoration. For this, we need to define SSR, which is self-service restore, and NGT, which is Nutanix guest tools. NGT is a software package installed inside the guest VM that enables advanced functionality, and SSR is what allows administrators or even end users to recover individual files from snapshots without having to restore the entire VM. But here's the catch, and you want to remember this. To enable self-service restore, the guest VM absolutely must have NGT installed. If NGT isn't there, you have to go into the Actions drop-down menu, click Install NGT, and specifically select the checkbox to enable self-service restore. Without NGT, SSR simply will not function, period. So when you trigger a manual failover to a target, like, say, an NC2 cluster, which is Nutanix Cloud Clusters, the recovery rolls out in 3 distinct phases. Phase 1 is Initiate Recovery, where the recovery plan is actually triggered. Phase 2 is Hydrate Data, where the snapshots stored in buckets like AWS S3 or Azure Blob are fetched and restored to the target site. And finally, Phase 3, Workloads Start, where your VMs boot up and actively start serving traffic. And remember, once they're up and running, you've got to configure the reverse schedule, often called a composite PR or protection rule, to ensure those newly active VMs are protected moving forward. Let's move to Section 5, Common Exam Traps. These are the strict edge cases and limits. This is where the exam designers really love to try and trip you up. Here's a scenario you might see on the test. You're tasked with configuring a recovery plan, and you decide to map networks that feature overlapping subnets. So what happens? Take a second to think about those architectural limits we've been discussing. The definitive answer? It won't work, and your network is going to be very unhappy with you. Recovery plans simply do not support overlapping subnets in a network mapping configuration. You must never create virtual networks with the same name or with overlapping IP address ranges when you're setting up these mappings. No exceptions. So, the crucial point here is that your configurations have to be mathematically precise. To use a virtual network as a recovery network on an on-prem cluster, the network prefix length must be an exact match, meaning if the source is a /24, the recovery network must be a /24. The gateway IP address must also match exactly in its final octet. And from a capacity standpoint, the total number of vDisks from all guest VMs and volume groups in your configuration absolutely cannot exceed 1,000. Memorize these limits, guys. They are Prive exam material for sure. And that brings us to Section 6, Key Facts to Memorize. Consider this your final exam cheat sheet. Let's lock this knowledge in with a rapid-fire review. Number 1. While Nutanix Cloud dynamically provisions VPCs, you have to manually create production and test virtual networks on your on-prem EZs before building a recovery plan. Number 2, test networks exist for one reason, to strictly isolate DR testing from your active production traffic. And number 3, if you're dealing with an MST-based recovery plan that's restoring to an NC2 cluster, it's going to throw a validation warning requiring you to manually update the capacity by increasing the number of hosts. Before we wrap up, I want to leave you with this provocative little edge case warning directly from the official documentation. Quote, if the disk updates between the snapshots, the restore process may not work as expected. End quote. I think this brilliantly illustrates the fragility of snapshot timings. It's a really stark reminder that even if you have perfect network mapping and flawless failover logic, your recovery point objective, your RPO, and the actual physical state of those disks are what ultimately dictate your success. Think about how that impacts your own DR strategy as you head into the exam. Good luck out there, and thank you so much for joining this explainer.